Welcome to Timber&Terra. I'm Glenn, and this project is working on trailer stakes. So I have two trailers and they're both here. Actually the subject trailer is that one, which is a 25,000 gross weight trailer. It's got the tandem dual wheels and it's got a beaver tail and then the attached ramps. This one here is 10,000, which I think is actually 10 OA, even though it looks like 100A. I think the model is actually a 10 OA. I don't know, overall, or I don't know, something like that. So it's a tandem singles, and it does have ramps, but they are, I think they're 8-foot ramps that are tucked in there. So this one is worth 10,000 pounds, even though it looks like it's built for 20,000. I mean, I think the main beam, which is either 10 or 12 inches, is about the same size as the beam on this guy. Interesting. Anyhow, but the axles are only rated for, I think, 5,000 each. So I have made stakes for this one, but the interesting thing is these stake pockets are slightly different sizes. So this is standard 2x4, which is 3.5 wide, 1.5 inch deep, and it fits well into these. So I have used 2x4s depending on what I'm carrying. Like if you're only getting something light, like say culverts, wood stakes will work fine. In fact, that's what these are. I just have screws on the end to keep them from going, falling out. But I did make some metal ones out of channel iron, and they fit in like this. And this way they're rather tight. And this is sort of a mishmash together. You see this, I just used scrap. I wasn't very neat about making it. This end here, actually flip it upside down, and these stakes fit on my off-road trailer. I used it, I think, once that way. But to make them fit tight, since the channel iron here is only 3, I don't think you can get 3.5 inch wide channel iron. When you get to 3 inches, it goes in inch increments, 3, 4. But I think you can get 2.5. But then it goes 2.5, 3, 4, 5, 6, etc. Up and away. And the depth here is about 1.5 or 1 3/8, depending on the channel. I'll go over how channels are designated in a second, but you can see here, this is how I made it fit tight. I put this plate on here, I welded and ground, as well as the sides to add that 1/2 inch. So to basically have that 3.5 by 1.5 inch. And it fits tightly here. It doesn't really have to fit tight left and right, so I really didn't need to do that, and I don't plan to do that with these new ones. But for a couple reasons. One is these do not fit in these. Even though the stake pockets are very similar, they are not the same. And you can see here, this does not fit in. So if we measure these stake pockets, it is, say, 1 9/16 inches by basically 3.5. Over here, we have just slightly different measurements. Got the same 1 9/16 inches, but is just under 3.5, which is fine for what I need. But 1 5/8, 1 9/16, I think is what they all measure. So these are two different brands of trailers. This is a quality trailer, which is the brand name. Not making any subjective opinion about its quality, and this is, well, obviously Big Tex. The other rationale for me making new stake pockets, or new stakes, is these. I'll include the top there, down to where it rests on the stake pockets, about just over 3 feet. So when I loaded this with 16-foot softwood logs, I used almost all of this 39 inches worth of stakes to put about 1,100 board feet on. I did not weigh it. I didn't have a reason to. When I sold the logs, they weren't sold by weight, so I never got the weight, but I was guessing it was probably maxed out at, you know, probably that 10, maybe a little excess weight, 10,000 pounds or so with that 1,100 board feet. So with this one, I want to, want to be able to do the same thing, max out the 25,000 gross weight, 20,000 roughly is the cargo capacity. So what I have for steel, I went a couple days ago to our my local steel supply house, which is about an hour and a half, and bought these 20-foot lengths of steel. It is so much cheaper to get 20 foot lengths, full lengths. I think in pipe and maybe even square tubing, it comes, I think, in 24-foot standard lengths. I never understood the difference. This is for a different project. This is 1-inch angle. This I'm going to use, and we'll see when I put this together. This is just a 1/4 by 1/4, sort of like key stock. This is the 3-inch channel iron, and this is some 3-inch flat. So we'll talk about, or I'll show you how this is going to go together in my plan. So if I took this 20 feet and divided it by 4 stakes, it'd be 5 feet each. So I can't go more than 5 feet, and I don't think I need to. So using the same sort of 2x4 test, it also fits in here. So they both meet the 2x4 test, although some do fit a little tighter than others, but they're basically all 2x4. So 3.5 by 1.5 will fit in both of them. And these pockets are, like I mentioned, a little bit bigger, but for the purposes of my need, it's not going to be, it's not really going to be a necessity to have them interchangeable, I don't believe. So as you can see, this is not the most effective. This was just sort of a local hardware store buy. I guess I need to get a higher quality one. The wheels are a bit off, but better than nothing. There's quite a bit of stuff there, but it leaves quite a bit behind. So let's talk about C-channels for a bit, because I have a couple. How C-channels are called out, and I think the same as with standard I-beams. They're with a single dimension, and the next number is pounds per foot. So these are the 3-inch channels that are generally available, and I have the 3-inch, which refers to this dimension here, by 5. So that's 5 pounds per foot. So for every foot in length is 5 pounds. I did end up cutting these 5 feet. I said I'm just going to use the whole 20-foot length. So they're 5 feet long. So 5 times 5 is, so 20, each of these is going to weigh 25 pounds. But the dimensions, other dimensions are slightly different. So here you can see for the one I have, it's basically 1.5 inches. That's this height here. 1.49497. Here it says 498. But let's look at some of these others, because I don't know what these are. These are ones that I picked up somewhere along the way. That's 144. It has a little paint on it. It might be 144. I don't know what that one is. It could be metric too. I don't. If it's metric, it wouldn't be 3 inches. So no, it's not ASTM or SAE or imperial, whatever term you want to use. The other dimension that varies a little bit is this web. So that's 2 say 266. So it's got to be that one, which is the same one I have. Interesting. So for whatever reason this, and you can see this has been ground a little bit, and maybe I was just not finding a good spot. So yeah, that's 4.9. This is basically the same as this. So this is the one, my current stake, which I'm pretty sure is a lighter duty one. 145. Probably that one. Let's look at the web. The web is 187. I'm guessing it probably is that one. I don't know why I don't have a closer dimension than that. But it's certainly not it's not a 1/4 of an inch like that one is. So this is probably 3 by 4.1. Just a slightly lighter duty one, and you can sort of feel it. But this one is going to be that 1/4 inch, 2.5. This should be 2.5 something. I don't know why I'm struggling so much. Help! Anyhow, so maybe my calipers aren't that accurate. Maybe I'm not using it correctly. But for the price, look at, for instance, take this piece here. 20 feet of this 1/4 by 1/4, which is a square round or like a key stock. That 20-foot length was $10. If you went and bought it, say Tractor Supply, the same thing, say a 3 or 4 foot length, it'd probably cost you 15. And here I can get 20 feet for 10. And even the channel, this size channel, you probably can't get, you know, like at a hardware store. But the 1/4 inch flat, you probably can by 3 inches. You know, 20 feet for $60. That's and here's one. I know you can get 1 by 1 at hardware stores. 20 feet of it for $27. It's just insanely cheap when you compare that to buying it in shorter pieces, you know, at a local Tractor Supply or other hardware type store. All right, back to the construction of this guy. Let me show you what this is going to look like on the trailer. It doesn't really matter whether the flat goes towards the inside or whether the ribs go towards the inside and the flat goes towards the out. But you can see here there's quite a distance, there's quite a gap. So there's less than a 1/4 of an inch of gap. So this 1/4 by 3, if I was to lay this just like this is going to be too thick, because that's going to be 1 3/4. So what I plan to do is just take a grinder and grind out, say, an edge. Either notch it out or just grind this at an angle so this sets down to match the, it's like 1 5/8, I think we measured, just over 1.5 inches. So it's, I'd say, between 1 9/16 and 1 5/8. So a strong 9/16, and we don't want it too tight because we don't want to have to sort of jimmy it down there. Well, after a lot of grinding, I finally ground out these corners. It fits really well, but this method took a lot, just using a traditional grinding wheel. I did have to finish it up with an 1/8 inch thick grinding wheel to get the corner a bit sharper. But it fits really well. Look at that, it almost makes some sort of a slide out of it. And I'm looking for 1.6 or less, which I have. That's 5.85. 5.89. .60. So I think I'm good there. Let's go try to fit this in the stake pocket, see if it fits well. So I have 3 more of these to do, but what I think I'm going to try, boy, if I had a milling machine, I could do this so easily. But I think what I'm going to do is take a cutoff wheel, which is like 0.045, so half the thickness of 1/8 of an inch, which I guess would be about a 1/16. And just sort of notch that out this way and that way, almost like you would, say, a piece of wood on a table saw to make a rabbet. So I'll try that and see if that works better. I'll probably still have to finish it up with a grinder and a regular grinding wheel just to get the fit well. Well, I still have cleanup to do, but that was a lot quicker. So basically this hunk of metal here, I saved having to grind away. So I'll finish the other side and clean this up with a grinder, make sure it fits, and I'll do the others, and then we'll come back when I'm ready to weld. Okay, so these are all cut out. That was a lot quicker to use that cut-off blade instead of grind it. I did verify the thickness is all less than 1.6. And as it turns out, I really didn't need any. They're not the best looking. There's some, there's a little bit of slivers of metal there still. But I didn't really have to do any cleanup. Just cutting that the way you saw was enough to make it where I needed it to be. So this is not really structural, so the welds are not really that critical. I just need to make sure I maintain the thickness. So my plan here is to just put a bead of weld along there. Some may extend beyond the surface. I'll just grind that flat. But remember, I have about a 1/2 inch of extra width there. This is only 3 inches, and the pocket is 3.5. So I'll just run a bead there, and then on the other side. And these 1/4 by 1/4 will go here. I guess I could have cut them 3 inches. I cut them 3.5, so they sort of span that. I'll leave them like that. I mean, it's sort of like the other ones that I had where they stick out beyond, and that seems to be fine. So that's what that'll look like. Well, it's not pretty at all because I had to stop a lot. It was hard to see for whatever reason. Maybe it's just because it's bright out, I'm not sure. This side is a bit better, so I had to stop and reposition myself so I didn't fall off the edge, so to speak. All right, so that'll work. I'll just clean up any welds that sort of protrude beyond the surface, and then we'll come back. Well, these are all set to go. I ground these all flat on this surface. I did take down some of the higher bumps over here, but I did actually learn a little bit, in at least in this particular application, going this way, pushing the puddle instead of pulling it worked better. The visibility, I was able to just barely see that crack as I was moving along, but there were still instances where I sort of veered off, mostly to the right here as we look at that. Okay, what I did learn also is that when I cut these plates, I didn't fasten it into that Evolution chop saw for metal, and I wasn't too concerned about it, and they weren't that square, so using this, I'm gonna actually weld these 1/4 by 1/4 key stock or square bar stock, I guess. They're not, I don't think they're key stock, because I think key stock is probably more precision surface. This is actually like a hot rolled finish. So it's square with the channel, but not necessarily parallel with the edge of this. So I want to keep this edge square. So if I do stick some weld in there, which I might, I'll make sure I grind it square so this can set squarely onto the trailer. So I'll put most of the weld there, and I may put a bead back there. I did cut 8 of these, but I'm thinking I only need 1 on each one. But we'll weld one on and try it and see what it looks like. Oh yeah, I only need 1 of them. So it's quite a bit of movement left to right, but front to back there's not much. I could have been a bit tighter with the thickness of this, but and I would have stood the chance of, you know, having it bind up, just not slide in easily, and it can go that way as well. All right, so I'll finish up the other 3, and then we'll finish up with a little discussion about another design option I contemplated before settling on this one and my rationale for it. And just like that, all 4 are done. They all look almost identical. So the other primary design I had considered was using rectangular tubing, which looks like this. So to get the same weight per foot, like I said, these are about 25 pounds each. This would have to be 1/8 inch wall all the way around. I think this is 1/8 inch. So this would fit in, I think. No, this is 2 by 3, I think. So it's a little bit too wide. But anyhow, they do have 3.5 by 1.5, I believe, in rectangular tubing. I thought about it, but the primary reason I decided against it was because of where this is going to hit. And most of the force is going to be one of 2 places. If this is, you know, if you picture this sort of pulling this way, the force is going to be along this edge and along that edge. And right here and all the way up. The further you get up, really, the less the stress is going to be on this member. But primarily because of here, if I had tubing, so right now I have a full width, which I would have had with here, instead of just these 2 points pushing against it. So you can see that piece of 1/4 inch that I welded on is actually all the way across here. But I would have had just 1/8 of an inch instead of 1/4 of an inch. So this is 1/4 of an inch because of the plate, and 1/4 of an inch on the web here of this channel. So if I chose this, it would have been just 1/8 of an inch, and I just thought it would have been much more likely to sort of fail or crinkle or bend right here at the point where it was hitting against here. So as far as the dimensions of this trailer, I don't think I mentioned it, or both of them. That one is 18 feet, and it's completely flat from head to toe. This one I think is advertised as 20 feet because that little bumper stop they have at the head of it, they count as the length of the trailer, but the 20-foot mark is there. So it's 20 feet of flatbed and another, I think it's 5 feet of beaver tail. Yeah, another 5 feet of beaver tail. So for 16-foot logs, you know, the 16-foot, I'd probably move it back a little bit from the very front, and I could either go here, this would sort of be probably within 1 foot of each end, or move them in. The challenge I have, though, is where to store these, because I don't have a place up here big enough to store them. But the shorter ones, the ones that are about 3 feet long, I can store in here. The other thing I noticed that's different about these trailers is the design, and I'm pretty sure it has to do with the dual wheels. So the main member here you can see is maybe, 14 inches or so from the edge, 12 to 14 inches from the edge, and it makes sort of a wide area here for storage. But on this trailer, and there's actually a couple differences I'll point out. This is the first one. So the main beam here, instead of being about a foot in from the edge, is probably more like 2 feet. Again, so underneath, well, there's a dog. Because this main frame has to be the inboard side of the dual wheels, so with a single wheel trailer it can be further out. So this little storage area here is a lot smaller. The other difference, and I think it just has to do perhaps with the diameter of the tires, I'm not sure. But here with the main beam, the channel irons, and this I think are, these might only be 2.5-inch channels, I never measured them. They just rest on top of the I-beam. On this trailer, it's a different style of channel iron. It's sort of a bent, so it's a slightly lighter weight one, but you can see it's actually punched through the web of this I-beam, which I guess lowers the deck a little bit relative to the surface here where the suspension is mounted. Okay, well, I guess that finishes things up. I appreciate you tagging along for this little project. Things are starting to dry out now, so I hope to be digging in the dirt here before too long. So thanks again, I appreciate it.